This is a circle, and a circle is a locus of points that's equidistant from a center. So this dot here in the middle is the center of our points. This length here is the distance from the center to that locus of points. This is known as the radius of the circle. And if I were to start at one end of the circle, go through the center, and end up at the other end, then I get essentially twice the radius, which we call the diameter. All right, and again, we said that this part is called the center of a circle. Something very interesting, and then of course, we're also interested in the length around the circle, which we just finished talking about polygons. You can think about it as perimeter, but with circles, we give it a special name because we like to be special. And instead of perimeter, we call it circumference. All right. So this is the circumference of a circle. This is the distance around. There's a special relationship that we have between the circumference and the diameter of every circle. So the circumference of any circle, any size circle you can find in your house, anywhere, the circumference of that circle divided by that circle's diameter will give us a irrational constant that we can approximate as 3.141592, and so on and so on. This is an irrational number because there are no two integers that we can divide to give us this number exactly. It is a non-terminating decimal that never repeats. It doesn't have any kind of pattern. It just goes on forever and ever and ever. All right? Now, you may have heard of this constant before, referred to by the Greek letter pi. Well, in our class, we don't refer to it by the Greek letter pi. And the reason we don't do that is because this particular constant was in use in the African Nile Valley nearly 2,000 years before the Greek alphabet even existed. This constant was being built into architectural structures and engineering marvels that are still existing today, such as the Great Pyramid. We can find the use of this particular constant literally embedded into the architecture. So for the purposes of this class, we don't use the Greek letter pi, which is what mathematics uses to represent this constant of the ratio of a circle's circumference to its diameter. Instead, in this course, we use the Medu Neter letter Y. So Medu Neter is the language of the ancient Kemetic people of the Nile Valley, the ancient Africans of the Nile Valley. You may have heard of it as hieroglyphics, but it's the name of the language is actually Medu Neter. So we like to, in this course, use this letter Y to represent 3.141592 65359, so on and so forth, all right? So in this course, do not be confused. Generally, in mathematics, they use the Greek letter pi, but it made no sense to me to use a letter that was only developed 2,000 years, nearly 2,000 years after this constant had not only been discovered, but had been used practically in engineering design. So we use the Medu Neter letter Y, all right? It means the same thing. It's just a constant representing this value. So given this, we now have a formula that we can use to define the circumference of any circle. And so that is that the circumference is equal to our constant, again, which we call Y, times the diameter of the circle. And since we know a relationship between the diameter and the radius, that the radius is twice the diameter, or we can say that the diameter is equal to 2 times the radius, we can then write the circumference in terms of the radius as 2 times Y, our constant, times the radius. All right, so these formulas we can use to calculate the circumference of any circle. Okay, so for example, let's say that we have a circle that has, let's say we have a circle that has a radius of 5 millimeters. And we want to know what is the circumference of that circle, right? So we can use one of these two formulas. Either we can find the diameter, which we can find simple enough because we know the diameter is twice the radius. So the diameter here is going to be 10 millimeters. So we can either use this formula or we can use this formula. I'm going to go ahead and use this formula. And so say that our circumference is equal to y times our diameter, which is 10 millimeters. All right. So often we will leave our answer in terms of the constant y. So in general mathematics, they would use it leave it in terms of pi. So we could write this as 10y like this, and that will be millimeters. Or we can approximate and say that our constant y is approximately equal to 3.14. And using that approximation, we can then say that our circumference will be approximately equal to 10 times 3.14, which would be 31.4 millimeters. All right? And so this is our approximate answer for our circumference. And we can use another formula to find the area of circles. And that area is going to be, or rather that formula is going to be that the area is equal to our constant y times the radius squared. And again, this constant, do not be confused. This is what in general mathematics they use the Greek letter pi to represent the ratio of a circle's circumference to its diameter, which is approximately equal to 3.14. But we, instead of paying homage to the Greeks who came thousands of years later, we pay homage to the Africans who were using this knowledge thousands of years prior. So y we use instead of pi. So this is how we can find the area of a circle. So for example, let's say we have a circle that has a radius of 10 centimeters. And we want to know what is the area of that circle. Well, we use our formula. Area is equal to y times the radius squared. So that's going to be our constant times 10 centimeters squared. 10 squared gives us 100. So our area here would be 100 times y. Or if we want to, again, approximate our constant y and say that it's approximately equal to 3.14, then we can say that our area here would be 314. And the units here are very important, centimeters squared. Okay, and that is basically it. Another example, let's say that we're given a circle has an area that's equal to 144 y square inches. So here we're given the area in terms of our constant, right? And the units here are square inches. And what we're trying to find is we're going to do some reverse engineering. We want to figure out what the circumference of such a circle is. All right. So what we're going to do, again, is we're going to start with our formula. Area is equal to our constant y times the radius squared. The area is given to us in terms of y. So we're going to substitute that. So we'll say 144 y inches squared is equal to y, just love saying that, times the radius squared. So since we have y on both sides of the equation, it essentially cancels out and we can get rid of it. And so then our equation becomes 144 is equal to r squared. And we can find our radius here by taking the square root of both sides of this equation. And we find that therefore our radius is equivalent to 12 inches. But we're not done because we're not asked for the radius, we're asked for the circumference. So we need another formula, and that's the formula for circumference, which is 2 times y times the radius. So that's going to be 2 times our constant times the radius, which we just found is 12 inches. All right, so 12 times 2 gives us 24 y inches. And this is our circumference. All right, and like I said, we often will leave this in terms of the constant. So 24y is the same as saying 24 times 3.14. And that is approximately equal to 75.36. So we can approximate this if we use y as 3.14 as approximately 75.36 inches.